Hello, it's me, Oscar from Marijuana Garden.
That is a mind-bending theory, and you've captured the core excitement and controversy around Stuart Hameroff and Roger Penrose's Orchestrated Objective Reduction, or Orch OR, model perfectly. Let's break down the key elements, the criticisms, and what the new evidence might refer to. The core idea of Orch OR is pretty fascinating. Hameroff and Penrose proposed that microtubules, those cylindrical protein polymers forming the cell's skeleton, especially abundant and organized in neurons, aren't just structural. They suggest these structures, particularly within pyramidal neurons, create an environment that's shielded enough from the noisy, warm, wet cellular environment to actually sustain delicate quantum states. Within these shielded microtubule lattices, electrons or other quantum elements could exist in superposition, meaning multiple states at once. Orchestrated by cellular processes, hence the term orchestrated, these superpositions could perform quantum computations. Penrose's unique contribution is something called objective reduction, or OR. He argues that quantum gravity effects, which are related to the fundamental structure of spacetime, cause these superpositions to collapse objectively, not just upon measurement, like in standard quantum theory. Penrose believes consciousness is this orchestrated collapse process. Each OR event is a moment of proto-consciousness, and complex orchestrated sequences give rise to full conscious awareness. So, by tying consciousness to quantum gravity, which is, the bridge between quantum mechanics and general relativity, the Orch OR theory suggests that consciousness isn't just some emergent property of complex computation, like what conventional AI theory would say. Instead, it's fundamentally woven into the very fabric of the universe itself. And well, this is really the basis for speculation about some pretty profound implications for perception, self-awareness, spirituality, and maybe even non-local aspects of the mind. Now, Orch OR has faced, and honestly still faces, a lot of significant skepticism, mainly focused on a few key points. Decoherence is, by far, the biggest hurdle here. See, maintaining quantum coherence, the state where superposition or computation actually happens, requires extreme isolation from environmental noise. We're talking about conditions like near absolute zero temperatures and a really high vacuum. Critics point out that the warm, wet, and chaotic environment of the brain would destroy any fragile quantum state way faster than the timescales needed for it to influence neural processing or conscious events, which happen in milliseconds. And, this whole idea of a shielded space in the brain is still highly contested. So, is there any known biological mechanism actually capable of orchestrating quantum computations within microtubules? Well, critics point out that there's just no evidence for the necessary control mechanisms here. For decades, direct experimental evidence linking quantum processes in microtubules to conscious states was, honestly, just lacking. Meanwhile, neuroscience has made some pretty significant progress explaining aspects of consciousness through classical neural networks and information processing without really needing quantum explanations. And then there's the issue of scalability. How do quantum events in these tiny, nanoscale microtubules actually scale up to produce the unified macro-scale phenomenon of consciousness? The proposed mechanism, well, it remains pretty unclear to a lot of people. So plenty of neuroscientists believe that complex electrochemical signaling across neural networks is actually sufficient to explain consciousness, without needing to invoke quantum mechanics in this specific way. While Orch OR still remains a minority view, research has progressed, and there are some potential support points that Hameroff and his colleagues like to highlight. Discoveries like quantum effects in photosynthesis, where energy transfer is super efficient, and in bird magnetoreception show that quantum coherence can in fact occur in warm biological systems. This really challenges the idea that it's absolutely impossible. So this proves that biological systems can exploit quantum mechanics, though not necessarily in the brain or for consciousness. So let's talk about anesthesia research, which is actually Hameroff's main field. It's pretty fascinating because anesthetics are known to selectively erase consciousness, while, other brain functions just keep going. Research has shown that anesthetics actually bind to microtubules and disrupt their dynamics. Hameroff argues that this specifically targets the quantum computational process proposed by Orch OR, and, well, that gives us a possible mechanism linking anesthesia to consciousness. Moving on, studies, including some that involved Hameroff, have shown that microtubules exhibit these specific resonant vibrations. According to Orch OR, these vibrations help facilitate and orchestrate the quantum processes that are thought to be at play. There's also evidence for coherent excitations, sometimes called Froelich condensates, in biological systems, and these might actually be relevant to microtubules as well. Now, looking at the bigger picture, the broader field of quantum biology is really gaining traction these days, which makes the idea of quantum effects in the brain a lot less implausible than it was, say, 30 years ago. Plus, research into quantum effects and other neuronal components, like spin effects and radicals, is contributing to a more open-minded environment in neuroscience. Penrose and Hameroff have, continued to refine their theory over the years, addressing some criticisms along the way. For example, they've proposed faster objective reduction timescales and suggested different locations within microtubules where these processes might occur. There are, some important caveats to keep in mind when considering this theory. It's important to note that Orch OR is still not the accepted model in mainstream neuroscience or physics. The decoherence problem remains a massive challenge, and honestly, the evidence that's been presented is often indirect or interpreted favorably by proponents. So, let's talk about the difference between supports and proves. The new evidence, it makes the theory more plausible or, less easily dismissed in the eyes of its proponents and some open-minded scientists. But it does not constitute definitive proof. Much more rigorous and direct experimental validation is needed. So, spirituality and the afterlife, these are honestly highly speculative philosophical interpretations that spring from the theory's connection to fundamental physics. Orch OR itself is, at its core, a scientific hypothesis about the mechanism of consciousness in the brain. Any claims about an afterlife, those are really extensions that go way beyond the core scientific model, and, just aren't testable within current science. You're right, it's a freaking crazy, in the best sense, and profoundly ambitious theory. Hameroff and Penrose really do deserve credit for proposing a truly novel, testable, though, difficult to test, mechanism that links fundamental physics to consciousness. While it's faced decades of justified criticism based on physics principles, recent developments in quantum biology and some specific research, especially around microtubule vibrations and anesthesia, have breathed new life into it, making it a more serious contender than it was, say, 10 or 20 years ago. However, the core challenge of decoherence in the warm brain, that remains the giant elephant in the room. Until this is conclusively overcome with experimental evidence that demonstrates sustained, functionally relevant quantum coherence in vivo in neurons, Orch OR will, remain a fascinating but controversial hypothesis on the fringes of mainstream science. The so-called new evidence is definitely exciting for the theory's proponents, but it just hasn't yet convinced the broader scientific community. It's definitely a theory worth watching as quantum biology advances.
Thank you.